Today we will study intersecting lines. Three or more points in a plane lying in a straight line are called collinear points. And if they are not lying in a straight line, then they are said to be non-collinear points. Here I have drawn on the board 3 points A, B and C. If I join these 3 points, I get a straight line. But points P, Q and R are not along one straight line. I can either draw a line through PR or through PQ, but I cannot have a single line passing through all these 3 points. Such points are called non-collinear points as they do not lie on a straight line. In a plane, 2 lines can cut each other, cross each other, intersect each other at one and only one point. Now here in the diagram, I have shown 2 lines AB and CD. Both these lines intersect at the point O in the plane. 4 angles are formed. I have named those angles are angle 1, angle 2, angle 3, angle 4. And we can also say that the angles are angle AOD, angle DOB, and angle BOC, and angle AOC. Before going further, I would like to bring to your notice that here I have drawn 2 lines which I can produce. And see, when I produce these 2 lines, then they are intersecting at a point. In the same way, in this diagram, 2 lines I have drawn, and again if I produce these 2 lines, they form intersecting lines. So 2 lines in a plane intersect each other at one point. Let us recall that AB is a straight line and angle AOD and angle DOB, both the angles are lying on the straight line on one side of the line. So the sum of these 2 angles will be equal to 180 degrees. Using this, we will find the angles relationship. Now angle 1 plus angle 2 are on the same side of AB. AB is a straight line, so angle 1 plus angle 2 is equal to 180 degrees. In the same way, angle 2 plus angle 3 is equal to 180 degrees because COD is a straight angle or CD is a straight line. So angles on the same side of the straight line sum up to 180 degrees. In the same way, I can say AB is a straight line, and on this straight line, angle 3 and angle 4 are on this side of the line. So angle 3 plus angle 4 will sum up to 180 degrees. In the same way, angle 4 plus angle 1 will be equal to 180 degrees as they are on the line CD, or they form the straight angle COD on the same side of the line. Now I have named these equations that I have written on the board as 1, 2, 3 and 4. Let us first take 1 and 2. Now angle 1 plus angle 2 is equal to 180 degrees. And angle 2 plus angle 3 is also equal to 180 degrees. So we can put both of them equal. Here I can cancel angle 2 because it comes on both the sides. So I can take away angle 2 from both sides of this equation. And I get angle 1 is equal to angle 3. In the same way, when I take second and third equation, I get angle 3 plus angle 4 is equal to angle 2 plus angle 3. In this relation also, angle 3 is common. So I write angle 2 is equal to angle 4. So I've proved that angle 1 is equal to angle 3, or angle AOD is equal to angle BOC. And angle GOB is equal to angle AOC. And these angles we call as vertically opposite angles. When two lines intersect each other, two pairs of vertically opposite angles are formed. And angle 1 is equal to angle 3 here, and angle 2 is equal to angle 4. Vertically opposite angles are equal. Now let's see the size of the angle. If I just look at the angle, angle AOD to me appears to be acute, and angle AOC to me appears to be obtuse. So two lines can intersect and they can form two acute angles and two obtuse angles. Another thing that I want to say here is that two lines in a plane, when they intersect in such a way that the angle formed is equal to 90 degrees. Here, the two lines are intersecting at a point. The angle between the two lines is 90 degrees. So see that all the angles, this angle, and this angle, all the angles will be equal to 90 degrees. Because from our result, vertically opposite angles are equal, then also this angle plus this angle will be 180 degrees. So again, this angle has to be 90 degrees. The fourth angle has to be 90 degrees. Next we come to three or more lines in a plane. Now three or more lines in a plane do not essentially cut at the single point. They might cut at three different points. So let's now only concentrate on three lines in a plane cutting each other at one point. And such lines which cut each other at a single point are called concurrent lines. The point at which they cross each other, they are called the point of concurrence. And here I have shown you PQ, RS, TU are concurrent lines. And O is the point of concurrence, that is where all these three lines meet, intersect, or cross each other, cut each other. So, two lines in a plane either intersect at only one point or they are parallel. In our next video, we will study parallel lines. If you enjoyed the video, please like it, share it, and subscribe to the channel. Thank you.